Hi guys, warm welcome on German's MATLAB coding. In this clip, we're gonna discuss how one can find imaginary axis crossing of a characteristic polynomial for a given control system in MATLAB. Viewer needs the background of clip 57 where we discussed how one can find the route table of a characteristic polynomial for a given control system. We know that the parameter s in characteristic polynomial is the sum of sigma and j omega, where sigma is the real axis and j omega is the vertical axis or imaginary axis. When characteristic polynomial is graphed for some control system gain that will cross the imaginary axis, our objective is to find the crossing point of the imaginary axis by the characteristic polynomial, and that happens by the second order or s square power of characteristic polynomial from the Routh table. In clip 57 we mentioned a characteristic polynomial which was s cube plus s square plus 4s plus 2 and whose Routh table was 14122020, but the return was accompanied with the powers of s, and our output was a 4 by 3 rectangular matrix where the first column refers to the powers of s and second and third column for the Routh table. Now the crossing point of the imaginary axis by the curve happens by second order power of s, and which is here second row, second and third column elements. Now, if the return is available in the variable r, then the position index of 2 2 for s square coefficient and position index for 2 3 for the constant term. Since s is missing, the coefficient of s is 0. So, as a complete polynomial, we form that by r 2 2, 1 space gap 0, 1 space gap r 2 3. On the screen, you see the repetition of the statements in clip 57. The only difference here is the variable r, where we put the return from the Routh as rectangular matrix. Viewer needs the background of clip 55, where we addressed how one can find the roots from a given polynomial, starting from its coefficients. Now, for the last given polynomial, the imaginary axis crossing is plus minus j 1.4142, which we would like to obtain in MATLAB. Now, go to MATLAB command prompt, enter the second order term from the Routh table and assign it to workspace S. S is user chosen variable. Then, in the next command line, call the roots with S as the input argument. After execution, you will see the imaginary axis crossing points, which is consistent with the earlier expectation. Alright, we would like to cease the session here. Don't forget to share, like, and subscribe our contents. We do need your encouragement. I hope to see you in next clip. Bye for today.